A basic way of getting a representative sample from a population is simple random sampling, where every member of the population has the same chance of being in the sample. Simple random sampling is conceptually easy to do. For a population of 70 plants in a garden, for example, a simple random sample can be constructed by numbering the plants from 1 to 70, using a random number generator like this random sample input to get a list of random numbers between 1 and 70, and then choosing the corresponding individuals from the population to get the sample. In practice, this can be quite difficult, however. It would likely be difficult or impossible, for example, to assign a number to every pebble on a beach, or to assign a number to every bird in a forest, or to get a simple random sample from a population where the size of the population is indefinite, such as a sample of people who enter a restaurant where the set of individuals in the population, which is the set of individuals entering the restaurant, keeps changing. One common variant of simple random sampling is cluster sampling, which works by separating the population into groups called clusters in such a way that each cluster is at least approximately representative of the population, and then sampling from a random sample of clusters. Cluster sampling could be done for pebbles on a beach, for example, by imagining the pebbles organized in square clusters in a grid, selecting a random sample of clusters, and collecting data for all of the pebbles in the selected clusters. Cluster sampling is often done when the population is naturally organized in clusters, such as people who live in similar communities, or in the garden example, if the plants in the population are in separate but similar garden plots. Cluster sampling in this example could be done by selecting a random sample of garden plots and collecting data for every plant in the selected plots, or alternatively by combining simple random samples from each selected cluster. Cluster sampling can sometimes be more accurate than simple random sampling, but the primary reason to do cluster sampling is that it is often easier or less expensive to collect data in selected clusters than it is to collect data for a simple random sample of individuals in the entire population. Another variant of simple random sampling is systematic random sampling, which is done by starting with some random individual in the population and selecting additional individuals at some fixed interval called the sampling interval. Again, using plants in a garden as an example, this diagram shows systematic random sampling starting with the 8th plant in the first row, and from there selecting every 18th plant in the garden. Systematic random sampling is usually unbiased as long as there is not some periodic pattern in the population. Systematic random sampling could be used, for example, to get a random sample of people entering a restaurant by collecting data from, for example, every 10th person to enter the restaurant. Another method of sampling, which is typically more accurate than simple random sampling, is stratified random sampling. Stratified random sampling is done by separating the population into groups called strata, or sometimes layers, of individuals with similar characteristics, such as groups of similar plants in a garden, and constructing a sample by combining random samples from each layer, or stratum, with sample sizes chosen so that the proportion from each group in the combined sample is the same as the corresponding proportion in the population. Stratified random sampling can be more accurate than simple random sampling because stratified sampling makes it possible to ensure that the proportions of identifiable groups in the population are accurately represented by those same proportions in the sample. Comparing random sampling with stratified sampling, randomization is useful for ensuring that groups within the population, including unknown groups distinguished by unknown differences, are, at least on average, accurately represented in the sample, and stratification is useful for ensuring that groups distinguished by known differences are accurately represented in the sample. The advantage of stratification is that groups can be made to be accurately represented in all samples, not just accurately represented on average.